So this is a very important limit. X is approaching to 0. Sine x over x. Now we can show that this is equal to 1. And to show that this is equal to 1, we got to use Squeeze Theorem. We don't know how to show, we don't know how to do the limit of x sine x over x. So we need to come up with two other functions that's smaller than this one always and greater than this one. Okay, so to get those two functions, we need this diagram. This is a circle with radius of 1. Okay, so it's a radius of 1. Let's call that theta. Okay, so what is this first line I've drawn? What is that? If this is 1 and this is theta, in trig ratio, what is that length? Sine theta.
Yeah.
You agree?
Yeah.
What about this length here? Okay, so if you have a circle, right? And this is radius, this is theta. What is L? L is r times theta. Do you guys remember this?
Yeah.
So this is L, and it's equal to 1 times theta, so it's just equal to theta in radian value, of course. Finally, what's this? Right, what is that length? The blue line, the longest blue line. That's equal to, okay, let's say I don't know what it is, right? Let's call it B. What is this length down here? 1, because it's radius. So what's B over 1 equal to? Tangent, so it's tangent theta. That length outside, if the radius is 1, is just tangent theta. Now, imagine that I'm rotating this arm here. Oops. Right? From here all the way through. No matter where this arm is, can you imagine that no matter where it is, it's always true that the sine theta will always be the smallest, and then it will be the theta that's larger than sine of theta, right? The orange is always in between, and the blue outside is always the largest in terms of length. Okay, so remember, we're doing this because we want to find out this limit, and we want to come up with a Squeeze Theorem relationship, right? Now, how can we get, from this inequality, how can we get sine x over x, or sine theta over theta? Divide everything by sine of theta.
No.
Flip all of them. Then we get this relationship that sine theta over theta, right, is always smaller than 1, but always greater than or equal to cosine of theta.
Okay.
So let's do the limit. Let's attach limit to all three sides. X, so theta approaches to 0. We don't know how to do this, but we know how to do these two, don't we?
Yeah.
What are they? One, one. They're approaching 1. So by Squeeze theorem, the answer is going to be the limit is 1. So what's happening again visually? So we're not sure exactly what that looks like, but we do know here's y equals 1. The cosine looks like this. and we have the sine theta over theta graph that always looks like this. It's doing something like this. So the limit, even though with the algebra we cannot do it with sine theta over theta, I know that it has to approach 1 by Squeeze theorem.